Hello. In today's session, we will discuss the operating parameters, temperature, current, and field, essential for the operation of superconductors. Let's begin with the agenda. As you can see from the title, there are three parameters necessary for maintaining superconductivity. I will explain each parameter in order. Through this session, you will gain an understanding of the three parameters required for maintaining superconductivity. To utilize superconductors effectively, it's crucial to maintain superconductivity during operation. The critical parameters of superconductivity include critical temperature, critical current density, and critical magnetic field. Considering these, determining the operating temperature, operating current, and operating field values is essential. Firstly, let's talk about operating temperature. Superconductors require a temperature lower than their critical temperature to maintain superconductivity. Coolants are used to achieve extremely low temperatures, and the boiling point of the coolant determines the achievable temperature. You can check the boiling points of different coolants in the table. Coolants exhibit weaker cooling power at lower temperatures, thus requiring more coolant and resulting in higher costs. The critical temperature varies depending on the type of superconductor and the cost of maintaining the coolant, as well as the type and temperature of the coolant, also differs. Therefore, it is important to comprehensively consider these factors when setting the operating temperature. Next, let's discuss operating current. The left graph illustrates the critical surface of a superconductor. By considering the aforementioned factors, once the operating temperature is determined, we can plot the graph of critical current versus magnetic field as shown on the right. When designing superconducting magnets, the target magnetic field is set, and the graph helps determine the corresponding critical current value. Typically, the operating current is set at around 70% of the critical current to provide a margin of safety against quench, which occurs when the operating current exceeds the critical current. Lastly, let's talk about target magnetic field. The desired location of the target magnetic field varies depending on the shape of the magnet. For example, the solenoid coil used in MRI and NMR, the racetrack coil used in rotating machines, and the saddle coil used in the LHC are designed so that the target magnetic field is located at the center of the magnet's geometry. On the other hand, toroidal coils used in nuclear fusion have the target magnetic field set at the center of the plasma. Additionally, the required magnetic field values differ for each application. Typically, solenoid coils are designed with a target magnetic field ranging from 1.5 to 45 Tesla, toroidal coils from 4 to 20 Tesla, racetrack coils from 2 to 10 Tesla, and saddle coils from 2 to 20 Tesla. Therefore, the design of magnets varies by application, with different target field values and positions being set accordingly. In summary, operating parameters, like temperature, current, and field, need to be selected carefully to maintain superconductivity. The temperature has to be below the critical temperature, but keep in mind that lower temperatures mean higher cooling costs. Usually, the operating current is set at around 70% of the critical current. The target magnetic field values and their locations can vary based on the magnet shape and the application field. That concludes the presentation on operating parameters, current, temperature, and field. Thank you for your attention.